We'll move on to the next part now, which is the master production schedule. So we have seen an aggregate plan and what it is like. An aggregate plan is a generalized plan. So if I have to give you an example, say for example it is an iron industry. The aggregate plan will only tell you how much iron ore has to be procured. Now, how do I know for what kind of casting and how much will be used for each kind of casting? I will have to have what is called as a master production schedule. As the name indicates, a master production schedule tells you exactly how many pieces are going to go into the production or how many pieces have to be manufactured. So based on the master production schedule, the aggregate plan will be modified. Now this master production schedule will go on to give us further details. What is the capacity that we require? How many machines, how much human resource, how much raw material, all of those things will be out of the master production schedule. And the aggregate plan also will, and the master production schedule will also tell us something about material requirement planning. Material requirement planning is detailed requirement of each and every material that is going to go into the production. So here if you look at this chart, it is an aggregate plan and the master schedule relationship. How are they related to each other? If you see that there are two different portions in this chart. So the market environment, that is what is the kind of environment in the market, what is the economy, what is the demand for a particular product, all that is known. So this market environment gives us a demand forecast. For example, if the market has a high and the economic values are feasible for the company, we make a demand forecast that the demand for a particular kind of casting is going to be high this time. So once we realize that the demand for a particular casting is going to be high, we will go on to see what we can do about the manufacturing process. So the manufacturing process will involve us to make an aggregate plan, an overall plan. That is a plan that is going to take us with how many hours in the day we have, how many kinds of work processes we will have, how many kinds of people we can involve. All of those things will come under the aggregate plan. How do we make this? We start from the market environment. Then we make a demand forecast. The demand forecast will tell us how many pieces that we are going to require to fulfill the demand. We will create an aggregate plan. Now once we have created this particular aggregate plan, also we need to take information from the other end. It is not just sufficient for us to study the market environment and make a demand forecast. We will go on to see what are the resources and data technology available. To suit this market trend, we will try to find out what resources are available, collect data using some sort of data technology, then the capacity of the plant which we have. What is the capacity of the industry? Small scale, large scale, medium scale, all those things will be decided. And then further, using this information as well, we will create an aggregate plan. Now when we have created the aggregate plan, the generalized plan, we will go on to create what is called as a master production schedule. A master production schedule uses details from the aggregate plan and tries to give us complete detail of what is going to happen during production. So the master production schedule divides the whole aggregate plan into two main parts. One is the material requirement planning, which will give you in detail requirement of every kind of raw material or subassembly or assembly that is required. So that is the material requirement plan. And then the capacity requirement plan. To produce these many numbers which we have got from the master production schedule, what should be the capacity? What should be the human resource number? What should be the capacity of the factory? How many machines will be used during that season? What kind of automation is required? All those capacity requirements also are told to us by the master production schedule. Now if you see, this is divided into three different terms of planning. When we are carrying out aggregate planning and master scheduling, we can divide it into three different terms of planning. The first is the long range planning. The long range planning is when we decide what kind of industry we are beginning or what kind of industry we are starting. I gave you an example of iron industry. In the long range plan, we will try to understand what kind of industry we are going to have. Is it going to be a casting industry? Is it going to be some other fabrication using already casted items? What are we going to do? This will depend on the market environment in that area. What is the requirement of that area? What is the highest drawback in that area? All those things are taken into account. Then we'll make a demand forecast. After this is done, we will see what kind of resources we have, maybe to procure the raw material, to get human resource, that is to find workers. Is it easy for us to get workers in that area? Is it easy for us to outsource what has to be outsourced? Is it easy for us to import what needs to be imported? How expensive will it be for transportation, logistics, all that is taken in the resources, and data technology available, depending on how remote the area is, how developed the area or the region is, we will have data technological problems which will have to be solved. Then we will see what is the capacity, the size of the industry that we have, the kind of infrastructure that we can incorporate. So these are all long range plans. These long range plans are plans that don't change. If they change, it means it will mean changing in the layout, changing in the type of industry. So they are all long range standing plans. Standing plans in the sense that once they are planned and once they are set up, we usually don't move from there. We don't deviate from there. The next is the medium range planning. The medium range planning will tell you aggregate plan, that is procure iron ore or procure whatever be the raw material that is being procured. Fabricating it into what is required is later. That comes under the master production schedule. This is a medium range plan because suppose I am doing this or I am carrying out an axle manufacturing process or procedure in my organization. I will have different types of raw materials. The aggregate plan will give me a general idea as to how many raw materials I need, how much of raw material I need to procure. And the master production schedule will tell me how many pieces are going to be produced. Now this is a medium range plan because if I change the kind of axle, for example, if I'm producing a rare axle, it will be a different type of an aggregate plan and a different type of a master production schedule. Suppose I want to add a front axle to it. I want to start manufacturing front axles, then this will change. So it is a medium range plan. It is liable to change. Not that the long range plans don't change, but they hardly change over, they take a long time. It goes over many years. So finally, if you see, this master production schedule reduces to material requirement planning and capacity requirement planning, which are short-term production planning processes. Why are they short-term? Every single time a batch is out, this might change, because the material requirement and the capacity requirement will vary as long as the demand is varying. Whereas aggregate planning and master production schedule hardly have any variations depending on the demand, because whatever be the case, raw material will be available. What can be stored will be stored. What can be used will be used. So this is an overview of the relationship between the master production schedule and the aggregate plan. The following table here also shows gives an exact explanation of what aggregate plan and master schedule is. So an aggregate plan looks like this. So there will be a month, like we have taken the example here of what I told you earlier, that is the casting. Suppose it is an iron industry and we are procuring castings, or we are manufacturing some sort of components for which we require to get the casting. When I create an aggregate plan, like in the table, we told you using regular time, you will be doing so much, giving so much of production, overtime so much of production. So that is for the time. Now, if I have to create an aggregate plan for how much casting needs to be procured, what I'll do is I'll prepare a table that looks like this. So January, February, March, April, May, June, July, August and September. Up to September, for 9 months, I'll create an aggregate plan. What does this mean? Tons of casting that will be procured at the beginning of each time period is given in the table. At the beginning of each production time period. So January is one time period. These are all single time periods of 1 month each. And here, in every time period, how many tons of casting need to be procured, need to be available on the shop floor or within the factory is given over here. So at the beginning of the month of January, 80 tons of casting or 80 tons of casting have to be procured. At the beginning of the month of May, 60 tons have to be procured. In the month of August, 120 have to be procured. In the month of September, 80 have to be procured. So this simply means that at the end or the beginning of each production time period, these many items should be available. This is the aggregate plan. It is not a master schedule. Now, what this aggregate plan does is, it feeds itself into the master schedule. The master schedule now, again for the same number of months or the same production time period, we go into details. Here we are only bothered about how many tons of casting that we are procuring. If you come here and see, we are moving on to see low carbon steel, alloy steel, cast iron, non-ferrous iron. Here we are only going to procure iron castings. We are not worried about, we are not going to mention in detail what kind of casting. Whereas here, we'll come to see, in the month of January, you need 20 pieces of low carbon steel and 20 pieces of alloy steel, 30 pieces of cast iron, non-ferrous 10 pieces. So like that, we have it for all the 9 months. Here, if you notice the difference, this is not detailed, this is general. This gives you a general idea of how many pieces you require, whereas this gives you a detailed idea of how many pieces will go into the production of every unit. Now here, one more thing you need to understand is that from this schedule, we go on to the material requirement planning. What we mean to say is, now for example, 20 pieces of low carbon steel, 20 pieces of alloy steel, 30 pieces of cast iron, 10 pieces of non-ferrous iron. What does this mean when I'm talking about material requirement planning? When I have these many castings that are there, for each and every product that I'm going to produce, how many pieces of each of these is going to go into the production? That is what is important, and that is what I will get in the MRP. Now, depending on the housing capacity requirement planning in the sense, how many machines do we have, how much storage and housing do we have, all of this capacity requirements will be coined again based on this. To accommodate all these things, to accommodate all these castings, all these kind of raw materials which we are procuring, accommodating it on the same site, this is what is going to tell us whether we have sufficient capacity or not. Now again, if you recall the previous flow chart that we drew, long-term planning and medium-term planning and short-term planning. The long-term plans we have not shown over here. These are mid-term plans. So for the whole time period of January to September, we have planned only for January to September. This is the aggregate plan. After September, it will change for the next time period. Based on this, for this time period, the master production schedule is done. After September, again it will change. Short-term plan, which is the MRP and the capacity requirement planning, might change even at every single stage over here. Suppose in the month of January, all the castings are not used, something has remained. I need to store it to be used next. Capacity requirement plan will change. The master production schedule, if there is a failure, some of the products, now if you are manufacturing a batch of 100 products, there is no guarantee that 100 products will be perfect. There could be failure, there could be breakdown, there could be some sort of item that is missing. To compensate for that, material requirement plan, again, it can change at any stage. So in which case, we need to understand that the long-term plans, though not mentioned here, are the long-standing plans. That is to do with the capacity requirement, to do with the database, to do with all the research and the resources wherever we are going to procure the raw material. All this will depend on what? Market survey which we have carried out. So the market survey will tell us what the market environment is like. Based on this, we will create a demand forecast that will tell us how much, depending on what we are going to produce for this entire time period, we will make an aggregate plan, a general aggregate plan. So to understand the word aggregate in simple terms, when you complete your engineering, people ask you what is your aggregate. Your aggregate is your overall score for all the semesters that you have studied, all the examinations that you have taken. That is your aggregate. And what is your specific plan? That means for each and every semester, you have a separate grading. Aggregate is average, right? So you take an average of all your scores and that becomes your aggregate. Now if you have to say semester wise you have a score, it is differing from from one semester to another. But put together, if I take an average, it will give me an aggregate and overall overview of how much you might have scored. You might be a 7-pointer, an 8-pointer, a 9-pointer student. It could be anything. In a similar way, an aggregate plan tells me in general for each month how many tons of castings should I procure. These castings being a combination of these 4 extra castings which we have mentioned over here. Then when I get into the specifics, combination of these 4, each alloy or each part, how many I need to procure. So that is the difference between the aggregate plan and the master schedule. Let's try to understand now exactly what happens during the master production schedule or the master scheduling process. So the master scheduling process, or the master production schedule as it is commonly called, has this as its flowchart in process. So here we see that there are three main inputs that get into the master production schedule. One is what is the customer requirement, then we go on to what is the demand forecast, and then we go to the aggregate plan. So depending on this, we have to make the master production schedule. So the forecasts and the firm orders, whatever the customer has placed as an order to the firm, is made into an aggregate plan. It is made into an aggregate plan. So the collective orders of every single customer to the organization is made into an aggregate plan. Further, this aggregate plan is used to create a tentative master production schedule. So a tentative master production schedule, meaning that it is not the final production schedule, it's not the printed production schedule. This is just the aggregate plan. Further, there are certain processes that will be carried out. Now here what happens is, the tentative master schedule is prepared and a trial feed is given, material requirement planning program, as well as a material requirement planning program. So what is done is, the material requirement planning program and the capacity requirement planning program take the tentative master schedule that has been got from the aggregate plan that is created, that is given by the forecasts and the firm orders that have been input into the system. Now here, this is a trial feed. Please note, these are not the final values. This is a trial feed on the MRP system and the CRP system. Why do we carry out this trial feed? To understand whether we have procured correctly what is according to the aggregate plan. Further, to understand whether the aggregate plan is actually in accordance with the actual orders that have been placed in the firm. So this trial feed on the MRP. Do we have adequate materials? When it is on MRP, do we have adequate materials? If yes, we go to the master schedule, we feed this into the master schedule. If no, we revise the master schedule. We revise the master schedule, give it into the tentative master schedule, and it is carried out again. This is for the material requirement plan. Capacity requirement. Do we have adequate capacity? If yes, we go ahead and print the firm master schedule. If no, again we revise the master schedule. Okay, again we revise the master schedule. Now here, one more thing that needs to be paid attention to is, these forecasts of the firm and orders here give information to the aggregate plan. Also, what is the service that is required, that also is entered into the master production schedule. Now, this aggregate plan that is there gives certain information. If there is any extra spare part that is needed, for example, if at all the bulk order is for a certain kind of brake system, and another additional order is for a brake system which has some extra appendages, has some extra additions to it, then what are the spare parts that are required? Feed it directly into the master schedule. What is the kind of service needed? Put it into the tentative master schedule. Carry out this process. If at all we have sufficient material and we have sufficient and adequate capacity, we go to the firm master schedule. We create the final firm's master schedule, and this is further sent to the MRP and the CRP system, that is the material requirement planning system and the capacity requirement planning system. So this will give us a fair idea as to how to start the production process. Without this process being carried out, we cannot begin with the production. Okay, so I hope the overview of the steps that are involved in the master scheduling process is clear. Now we will go and understand what are the methods in which we can carry out this master production schedule. Now we will see what are the different master scheduling methods that we have. So the methods of carrying out a master schedule or the methods of monitoring a master schedule are carried out in three different categories. So depending on what kind of category we are using, we can carry out. So depending on what kind of industry we have, the method changes. So the first case is policy guidelines. When the master production schedule is created, based on certain policy guidelines that are there, we say that we are doing the MPS by policy guidelines. So we have been asked or instructed every time in the master production schedule to use an aggregate process plan. You always have to use an aggregate process plan. So create it first before you go for the master production schedule. Schedule common modules whenever possible. What do we mean by this? If a particular worker and a machine can be used for multiple operations at once, then we need to plan it accordingly so that we can reduce lead time, we can reduce machine usage and increase the utility of the machine. Like for example, if it is a CNC lathe and thread cutting and maybe facing can be carried out at the same time by the same worker on the workpiece. So instead of just doing thread cutting at once and then bringing the workpiece back again or sending it to another machine just to carry out another turning operation, then what we can do is we can combine the two and reduce time, money as well as usage of manpower along with utilization of the machine being increased. Load the facilities realistically, keep the capacity in mind before we put any raw material or any semi-finished product onto the working area for production. Release production orders on a timely basis. So this has to be kept in mind. If we want the production to be completed by a certain time, then we need to make sure that whatever raw materials, whatever sub-assemblies, whatever is required is available on time at the location or site for production. Monitor the inventory. The inventory has to be monitored on hand when there is demand, when there is no demand. How is it coming into the organization? How is it coming into the factory? Is it there available? How much is being procured? Because depending on this inventory decides a lot of things, mainly idle times. If depending on the inventory, if we have excess inventory, work can be carried out very easily, but the disadvantage of that is that time and space will be But the disadvantage is that space and finance will be highly utilized if we have excess inventory more than required, and having less amount of inventory will cause idle times at the machine and of the worker, because they are going to be waiting for the product to come and get stocked at the site of working. Reschedule as required. So if at all there are any changes, maybe a design change, maybe a time change, maybe the number of products changing, this can be rescheduled, not always, but if it is required, it should be done. So this is one way of doing a master production schedule. Another way of doing it is for strategies, for various strategies. Now, generally companies have three different strategies depending on the kind of industry. The first one is make to stock. Make to stock. So make to stock means the company or the factory continuously produces work, continuously produces items and stocks them up. For example, if we are talking about a bolt and nut industry, whether there is a demand for it or not, they assume that there is always a demand for it. It is made and stocked up and sold from there. So every time the company is running, every time production is taking place, it is not based on any particular demand. It is continuous in nature. So it is made and stocked. If you observe here, there will be large number of raw materials which are converted into end items. The number of end items are fed into the master production schedule. The number of raw materials is more than the number of end items. So the example for this is mass production. It could be a pipe manufacturing industry, it could be washers, it could be bolts and nuts. All these kind of industries, they come and they use this strategy. They make the workpiece and they stock it. The next is assemble to order. Assemble to order in the sense they make it in batches or make it in bulk. For example, if you are having a watch industry, certain types of straps will be manufactured, certain types of dial shapes will be manufactured, certain types of colors will be manufactured. These will be made and kept aside. As and when required, they will be made into a sub-assembly. For example, 2 straps and a dial. I will only change the face of the watch later on. But here, if you have raw materials will be more, and then here, these raw materials will be combined to form smaller sub-assemblies. These sub-assemblies further will go with different combinations. So I might have a batch of black watch straps, a batch of purple watch straps, a batch of square-faced watches, a batch of round dial watches, some triangle dial watches. Now, these will be put into sub-assemblies. These are all sub-assemblies. So, they will be lesser in number if you go to see and fed into the MPS. The end items, maybe an order has been placed for a round dial watch with a black strap. So, that is assembled and dispatched. This is in the case of assemble to order. So assemblies or sub-assemblies are made and stocked, and as and when the end items are placed or the order is placed, these are dispatched. The third one is make to order. Make to order concentrates on end items. end items which will be used as raw materials elsewhere. For example, if I am a fabricator and I am carrying work with steel, so you see many of the steel works, iron works, shops here and there. So their job is just to do what? To create some sort of end item which is going to work as a raw material somewhere else. For example, a person who has a steel workshop or a person who has an iron workshop, maybe is only going to use the process of welding and that particular raw material, that is steel. Create an end item and keep it. The iron rods that are used in buildings, they are not manufactured only when you want to create or when you want to construct the building. You can just go to the showroom and pick up how many ever rods you need. So such kind of an industry, a fabrication industry, they have many end items. It could be a rod, it could be a wire, it could be a billet, it could be anything. They have many such end items which have been made by the factory, and they are going to be used as raw material elsewhere. So they are going to be used as raw material elsewhere, and that lesser raw materials are fed into the master production schedule. These raw materials are what people will use for their work. The third is the monitoring of the master schedule. This has to be monitored. Based on what? Delivery promises. Have they been keeping them or not? How many delivery promises were kept? How many were unkept? What has happened to the inventory? How does it look? Does the inventory, is there a shortage or is there excess at all times? What is the capacity? Capacity, is there a production mismatch because of the capacity? Is there a production mismatch because of the requirement planning gone wrong? Then we have to see the confidence of both the workers as well as the supervisors. Are their confidence levels always high? Are they low? What are the causes? And then the last one, stock when there is no demand. How does the stock look like? Is it completely nil or is it in the safety level? So these are the three methods with which we need to create the master schedule, or the three methods which can be followed while creating the master schedule. Let us solve a problem now to see exactly how the master production schedule works. A company produces a motor assembly that is used in several handheld appliances. It has 60 units in stock and will manufacture more in production runs of 90 units. Develop a tentative master schedule for the demand shown in the table. A table has been given to us which is filled with the demands from various sources. When we were seeing the process of aggregate planning and creating a master production schedule, we saw that we had to take information from various orders and various forecasts to the firm. So based on this information, we have been asked to create a tentative master production schedule. A tentative master production schedule is one which is going to be tried on the material requirement planning software as well as the capacity planning software. It is not the final master production schedule. So the first thing that you need to note here is this table gives you forecasts and orders. If you recall the chart that was presented earlier, then you will remember that the first input to the aggregate plan before creating the master production schedule is the information regarding the orders from customers and firm forecasts. So depending on that, all the information is given to us here in this table. The initial inventory at the beginning of production is given to us as 60 units. The production lot is 90 units. What do we mean by the production lot being 90 units? Every time production takes place, 90 units have to be produced. Every time production takes place, 90 units of the product have to be produced. So that is what it means by production lot being equal to 90 units. Initial inventory from a previous order is 60 units. So when starting production, we already have 60 units on hand. Here we have the customer forecast, interplant forecast, customer orders, warehouse orders. What we are going to do here is, for every time period, it is in weeks, we will find out what is the gross requirement for every single week. So here we will find the gross requirements for every single week. How will we do this? We will do this by adding all the requirements in the table. Okay, so here we will add these two and get 55. Again 55, 65, 55, 60, 40 plus 5 plus 5, 50, 50, 50, 55, 100. We have just got the gross requirement by adding every single weekly requirement that is there. Forecasts and the orders. Sum them up, you will get the gross requirements for the end of each week. Using this, we will prepare a tentative aggregate plan. Now, how do we do this? We will create another table which is going to ignore all of these parts and use only the gross requirements to tell us how to proceed with the aggregate plan. So, let us try to formulate this tentative MPS, that is the tentative master schedule. We have found out the gross requirements from the previous table. That is, we added whatever orders we had, whatever forecasts we had made, we added them and we got the gross requirements. So what did we get as the gross requirements? We have to list them in this table. Now that we have listed the gross requirements from the previous table here, the next thing that we need to do is we need to look at what do we have as an inventory from a previous order. So available on hand, I have mentioned here minus 60 in the sense after the initial inventory, how much do we have at the end of each time period. So here what we are going to do is we are going to carry out a calculation. So now when we are starting to fill up this table, we notice that there is 55 as a requirement in the first week. Now we already have 60 units on hand, available on hand. So if we use this 60 units to satisfy part of this demand of 55, we will be left with 5 units at the end of the time period. What did we do? Initial inventory of 60 minus what is the requirement, that is 5. These 5 units can be carried on to the next time period. One more thing is, here 55 has been fulfilled, 5 units have remained. We don't need to carry out any production here. Going on to the second week, we have only 5 units from the previous time period. We have 5 units from the previous time period. Now, you need 55 units here, but you have only 5. Here, in the question, it has been told to you that production lot is 90 units. That means every single time production takes place, the number of units produced should be 90. So here, whenever we are going to carry out production, we have to produce 90 units. 55 units are required over here. 5 units are already available. You cannot make just the difference. We have to produce 90 units. Production will take place in the second week. 90 units will be produced. So what will be the available on hand here? The available on hand will be, production is 90 units have been produced, plus 5 units that were remaining from the previous time period, that is 90 plus previous time period 5, that is 95 minus 55, that will give us 40 units. So what did I do? Available on hand from the previous time period, from week 1 plus production minus requirement. Meaning from the previous week plus the production minus requirement. What remained from the previous week? 5 units remained from the previous week, plus production we produced 90 minus the requirement which is 55. This gives us 40. This is available on hand at the end of week 2. Again, moving on to week 3, 65 is the requirement, we have only 40. Again, production has to be carried out. Always in lots of 90 units, nothing less than 90 units. So here what do we have? 90 minus 90 plus 40 minus 65. 90 plus 40 minus 65. So this will give us how much? At the end of this week, we will get 65. So at the end of week 3, we have 65 units. Moving on to the next week, requirement is 55. We are having 65 on hand. So we don't need to carry out any production because we can use it to fulfill this. So when we are using it to fulfill this, we will use 65 units from the previous time period available on hand to satisfy part of this demand, leaving us with 10 surplus available on hand. This 10 surplus we will take it to the next time period. We are having only 10, we require 60. Here production should take place 90 units. So this becomes 100 minus 60. So here again we are going to have 40 units. 40 units we will use it to satisfy this, but we cannot because available on hand is less than requirement. So here again we have to produce 90 units. Available on hand is 40. We will produce 90 units. So here what will be remaining? Again we will be left with 80 units. That is 90 plus 40 minus 50. Available on hand is 80 units. 80 units are present over here. 50 is the requirement. We can definitely use it to satisfy this demand. We don't need to carry out production over here. After using 80 units to satisfy the demand in week 7 of 50, we will be left with 30 units. So these 30 units that we have, we cannot use it to satisfy the next week's requirement, in which case this 30 has to be added surplus with 90 units again produced in week 8. So 90 plus 30 again minus 50 and we will have 70 units. The requirement for week 9 is 55. Then the requirement for week 9 is 55 and the remaining is 70. We don't need to carry out production here in week 9. We can use this 70 to satisfy some part of the demand over here, leaving us with 15 more units. But again, in the final week, that is week 10, 15 units that are available or 15 units that are there from the previous time period, we need to carry out production and then we have to satisfy this demand. 50 units will be satisfied from this and we will be left at the end of this time period with 55 units. So the available on hand for the next cycle will be 55 units. Now that is just the solution to the problem. You don't have to do anything else because you have been asked only to create a tentative MPS.